All right, I have some help for you. I'm going to walk you through how to answer these questions. I want you to be not so much going to sharing sites, but to be asking questions and letting me help you with that. So we stay consistent with the correct vocabulary, what we're using in class at this level to answer these problems. When you go online, the problem is you can find correct answers, but you may be answering at a level that we're not teaching at for this course. So we have the logarithmic properties, which you can find in Quizlet. You can find in the course content, but I've collected these for you in Quizlet. So go into the course, which you should be doing weekly, daily would be ideal, and looking at the announcements, following my instructions and asking questions. All right, so we're going to refer to these to answer these questions. So let's just start with question number 1. Arjun incorrectly writes log base 7x plus log base 7y minus log base 7z as a single logarithm. Now, I do not want you typing at this level in this course. Please avoid typing your answers unless you have okayed it with me. If you have some kind of accommodations to type, we should be avoiding that unless you have special circumstances where you must type. You should be working on your own paper. So let me pull out some paper and show you what I mean by that. All right, I've got a blank sheet of paper, just notebook paper. I'm going to put question number 1. You don't even have to put a title on it. You'll title it whenever you save your document to turn in. All right, so we have log base 7. I'm going to go ahead and write down the initial problem. X plus log base 7 y minus log base 7 z. Now he writes that as log base 7 x plus y minus z. So let's look at his answer. And if you're noting this, he's just taking out the log base 7. I'm circling that. Let me highlight it so you can see it. It's taking out the log base 7. And then just writing what's left over. So what's left over is log base 7. Pull that out to the front, kind of like we're factoring out a variable. And then we're left with x plus y minus z. But this isn't algebra where log base 7 is a variable. So the mistake is he's using algebraic properties instead of the rules for logarithms. Let me bring this back up here. And this looks familiar. We're going to start with the first 2 terms. So we have log base 7 x, let me just look at these 2 terms here, plus log base 7y. So that property is called the product rule. So what that means is we can pull out that log base a and write that as log base a x times y, not x plus y. So let me just look at these 2 first and write this as log base 7 x times y. Now we still have minus log base 7 z as in zebra. Now let's look at our properties. This right here is going to be the quotient rule. We're subtracting now with the same log base. So we're going to take whatever's here and whatever's here and divide. So right here, I have, let me write my log base 7. I have x times y. We're going to divide that by whatever's here by z. So this is our correct answer. And we'll go back, make sure that we've answered the question. Where did Arjun make errors? We've already explained that he doesn't understand the properties of logarithms. He's not applying those. So maybe he hasn't really practiced enough to let that sink in. Or maybe he doesn't have these nice handy-dandy notes to guide him. But he's using algebraic properties instead of the logarithmic rules. All right, so we've explained his error and we have stated the correct answer. Now we're going to move on to question number 2. All right, so now we have Helen and Stephen who both simplify the exponential expression. It's very, very hard to see. It's really, really small. So let me start by rewriting this. My camera's crooked, so let me adjust that. All right, so for question number 2, start by writing the question, the problem. The problem is e raised to the 4/3 ln 2 minus 1. So let's first work out what we think the answer is, and then I'll use that to compare to the answers that Helen and Stephen gave. All right, now when we use the e, which is Euler's number, we're going into the natural logs. Okay, so what this is we're talking about e, so we're having the natural log, which is the same thing as log base e. So we're raising e. Let me just rewrite this as log base e so you can see what I'm talking about. So when we have a number here and we're raising it to a power that has the same base in it, which is e, this is going to help us simplify. But before we start looking at this, we can take that 4/3 and bring it up over here. Now the log base e and the e will cancel each other out. We're not going to look at that. We're going to evaluate 2 to the 4/3. And then I'll move on to this in just a minute. Let's stop right here and write 2 to the 4/3. Simplify that. So remember, the 3 is the root and the 4 is the power. Okay, so we're going to write 2 under a cube root, and we're going to raise that 2 to the 4th power. Okay, let's keep working on simplifying that. Okay, this looks like 2 times 2 times 2 times 2. And when we're trying to simplify a cube root, we're taking out multiples of 3. 1, 2, 3. We've got 3 2's right here. So that can come out from under the radical. So we'll have a 2 outside of the cube root, but we're still left with this straggling 2. It doesn't have 2 more to pair up with or group with to bring out from under. So we simplified this first part, this part right here. Now let's evaluate what the natural log, or e to the 1 is. We're going to have to use our, let's look at this for a minute. We're going to have to use our quotient rule. Okay, when we're subtracting, okay, it's going to look like this. We've already simplified this top part. Okay, subtraction means we're going to put this over. Okay, now let's evaluate what e to the first power is. E to the first power is, we don't have a log here, so we can't cancel out that. E to the first power is just e. Okay, so all of that put together is 2 times the cube root of 2 over e. I think this is going to be the hardest one for us to really look at, because even though this is the same thing as any other log base, this Euler's number or natural log, it just looks different. It requires a little more practice. All right, so let's compare that with the answers that Helen and Stephen gave us. So if we look at what Helen did, she got this e in the natural log, and then 2 to the 4/3. So she got that right. And she also got e to the first power, and she got the quotient property. She got that e down on the bottom. That's what subtraction means. Okay, but when she simplified, she's using this 4 as the root and the 3 as the power. 2 to the 3rd power is 8. So she just switched these things up. All right, so she got confused on that last step on how to simplify 2 to the 4/3, but everything else looks correct. Well, let's see what Stephen did. All right, Stephen has e to the 4/3 and then times 2 minus 1. So Stephen didn't remember that this is going to be raising 2 to the 4/3 power. He's multiplying, okay? And then he's not really doing much else up here, okay? When he gets 8/3 minus 1, which is 3 over 3, he gets 5/3, and then he writes it this way. So this is a good try, but it's not the correct answer. We've got to use those properties. We've got to understand those. So make sure that you, again, on this, it's not about stressing out, getting the right answer so much as it is practicing with these properties, getting comfortable with these, and having a place to start before you take your final unit test. All right, so let's go to the third question. There are several parts to this. It doesn't count anymore. It's just really giving you several questions to practice with and then apply it right here on part B. All right, so let's solve the logarithmic equations. Remember the steps. We're going to start with the base, write the base down, when we're going from log to exponent form, and then we're going to move in counterclockwise direction. This is always going to be the exponent. So 4 to the m power is equal to, and then keep moving around here, is equal to 64. So we're going to look at that for a minute. Now you don't have to pull out your scientific calculator because we're just starting with this. So this should end up nice and neat. We're asking, first of all, let's look at what 4 to the 2nd power is. What's 4 times 4? That's 16. If we move one more step and multiply by 4 again, what is 16 times 4? 16 times 4 is 64. So that's what we were aiming for. So 4 to the 3rd power, right here, 4 to the 3rd power gives us 64. So m is equal to 3. Okay, make sure you understand that. If we have a 3 here, 4 to the 3rd power equals 64 is a true statement. Now let's move on to number 2. 8 to the 3rd power is equal to n. Let's write that in exponential form. 8 to the 3rd power is equal to what number? So you're going to get your calculator out, scientific or just a simple calculator. 8 times 8 times 8 is 512. So n is equal to 512. we're getting that practice and going back to the very beginning, converting this to logarithmic form. All right, let's try another one. P to the third power equals 4,096. P to the third power is equal to 4,096. So I like to take out my scientific calculator and find the cube root of 4,096. And when I put that into my scientific calculator, I believe I got the answer 16. Let's test that out. 16 times 16 times 16 is 4,096. Okay, that's correct. So P is equal to 16. Okay, let's try one more before we go to part B. All right, 32 to the third power is equal to Q. Okay, this one pretty straightforward. 32 times 32 times 32 is 32,768. So Q is equal to 32,768. All right, I think I skipped one. I missed one in between there, but the purpose is for you to practice before we answer part B. Study the pattern in the equations. Use your observations to solve the equation for A. Express your answer in terms of X. All right, so I think I may have really need to make sure I'm focusing on what I'm looking for. We're going to solve for A. So we want A equals. We don't want X equals. So first let's write this log form as an exponential form. So this is really tiny. Let me write that bigger for you. That says 4 to the x power. This is our base. 4 to the x power. And remember, using this pattern, don't get thrown off, because this is being raised to the x power. 4 to the x power raised to the third power is equal to, and this is always going to be our answer. And right here we have 2 to the a. Okay? All right, so now we have an equation that we can work on solving. Remember, we're looking for a. When we raise an exponent to a power, we multiply these. So this is 4 to the 3x equals 2 to the a. Now we need to have the same base. If we have the same base, we can set our exponents as equal. And I can easily write, let me see, I think I may have gone off camera. I can easily write 4 as 2 squared. So 2 squared to the 3x is equal to 2 to the a. Go slow. You can do this. It's just variables and numbers. All right, when you raise a power to a power, now I'm using my exponent rules. And again, these should be in your notes, or you can use the Quizlet study set that I have built for you. And here are our exponent rules. When you raise a power to a power, you multiply those. So that's what we're doing here. So we're going to multiply 2 times 3x. So this is 2 to the 6x equals 2 to the a. Now that we have the same base, we just mark those out and we set up this equation. 6x is equal to a. 6x is equal to a. Now we're solving for a. Solve for a. So here it is. A is equal to 6x. If I had asked you, and I think I made this mistake in working with some of you earlier, I just saw in terms of x, and I didn't read carefully. I solve for x, and if you're solving for x, you'll get a different answer. You'll get a over 6. So make sure that you are answering the question. The purpose is to practice and apply your rules. Make sure you have your notes ready. Don't make this harder than it is. And after you take your first attempt, Remember, I won't be available next week. Come in for Help Lab, and our focus is going to be on our unit test. All right, thank you for watching. Get this done and rest. Take care of yourself. Reach out for help.